Welcome to this VMC leveling video. This VF2SS is connected to air and power and is operational. However, the machine is not at the proper height or level to provide optimal performance and accuracy. There are 3 steps to the leveling process. First, the machine is positioned at the correct height above the coolant tank. Second, level the machine front to back and side to side to permit good coolant and chip flow. Finally, remove any twist or bow in the base casting. The tools needed for this procedure are a 3/4 inch socket and ratchet, a 1.5 inch wrench, a tape measure, a 5/10 or 1 micron test indicator and a magnetic base to mount the indicator, and Haas leveling tool T2181. A precision machinist's level is also acceptable for taking level measurements. This video features a VF2SS, but the same procedures apply to all VF series machines. Larger machines with outrigger supports require additional steps during the leveling process. This information can be found in the Haas Machine Installation Manual. To clear the coolant tank, lift the base casting 3.5 inches off the ground by adjusting the 4 corner leveling screws to the same height. On base castings with 6 or 8 leveling screws, the middle screws should not be touching the pads during the leveling procedure. Move the X and Y axis until the table is centered. Clean the table surface and the leveling tool. Make sure the calibration of your level is correct before starting. Place tool T2181 on the mill table and monitor the exact position of the bubble on the precision vial. Using a T-slot for alignment, rotate the level 180 degrees and place it in the same position on the table. The bubble should stay in the exact same position. If the values are different by more than 1 division, then the level should be returned to Haas for adjustment. With the leveling tool at the center of the table and the short leveling vial parallel to the Y-axis, the shorter vial is measuring the angle of the machine front to back. Lift either the front or back of the base casting as necessary to make the machine level. Remember to always lift the lower end of the machine to maintain clearance to the coolant tank. Each time you make an adjustment, turn both leveling screws on that end an equal amount. Adjust the screws until the bubble is centered. Adjustments close to 0 will make subsequent changes easier. With the machine leveled front to back, use the longer precision level lying along the X-axis, which shows the angle of the machine from left to right. Again, lift the lowest side of the machine to bring it level and turn both screws an equal amount. With the machine now level front to back and side to side, continue using the longer vial parallel to the X-axis. We are now ready to check for twist in the base casting. Start with the mill table at the front of the machine. Look at the position of the indicating bubble. Move the Y-axis across its full travel, stopping at the column. At the column side, look to see which rear corner of the machine, if any, is lowest, as shown by the leveling tool. In this video, the leveling tool is angled down at the right rear corner of the machine as we get to full axis travel at the column. This shows the right rear corner of the machine is low. The value is 3 marks away from 0. Lift the right rear corner of the machine until the leveling tool reads 0. Now move the table to the front of the machine and note which side is lowest. Adjust the lowest corner up until the leveling tool reads 0. Move the table across travel and each time adjust the leveling tool value to 0 by lifting the low corner of the machine. Usually the value will change several times and get nearer to 0 with each adjustment. Repeat this step until the bubble is adjusted to 0 at both ends of the Y-axis travel. Next, adjust the middle leveling screws until lowered onto the leveling pucks. Hand tighten each screw onto the puck until the puck stops turning. Set each screw by tightening an additional 10 degrees. With the middle screws tight, the remaining steps in this process are re-measuring for twist and measuring for bow in the base casting, and then measuring the spindle sweep. Any adjustments from this point forward will be done with the middle screws only, with both middle screws adjusted the same each time. These adjustments should be very small as we are almost finished. With the leveling tool still parallel to the X-axis, re-measure for twist. Start at the operator side, move to the middle of Y-axis travel, and then to the column side. Adjust the middle screws to remove any twist caused when the screws were tightened. Again, only very small adjustments should be made to the middle screws while re-measuring the level values. Next, measure for any bow, either up or down, along the length of the base casting. Place the leveling tool in the center of the mill table with the precision vial parallel to the Y-axis. Look at the bubble position at the operator side, at the middle of Y-axis travel, and at the column side. If the measurement shows there is bow in the base casting in either the up or down direction, use the middle screws to make adjustments. Remember, only move the screws in small and equal amounts. The tolerance for both the twist and bow measurements is 2/10 over 10 inches or 0.02 millimeters over a meter. Errors because of twist or bow will cause errors in the spindle tram values. With the twist and bow adjustments complete, carefully remove the leveling tool. Attach the test indicator to the magnetic base. Move the spindle head down to the middle of Z-axis travel. Attach the magnetic base to the spindle. Position the test indicator to measure a 10-inch or 250 millimeter diameter circle. Move the table to a position where the test indicator tip will remain on the table's surface when facing both the front and column sides of the machine. Moving the Z-axis in tenths mode, bring the test indicator down to contact the mill table and zero the test indicator. Take a measurement every 90 degrees of rotation. This provides two values along the Y-axis and along the X-axis. Total indicator reading for all four positions should not exceed 5/10 or 0.013 millimeters. If the spindle sweep is not within specification along the Y-axis, we can use the middle screws to make very small adjustments to the sweep readings while changing the bow and twist values by a negligible amount. Each time you make a middle screw adjustment to change spindle sweep, be sure to re-zero your test indicator at the operator side before re-measuring the effect of your adjustment. This will minimize the chance of confusing values. In this video, the test indicator starts with a value of 0 facing the front of the machine. We see 1/10 at the right-hand quadrant, -2/10 at the back side of the table, and 2/10 at the left-hand quadrant. If the value at the back had been out more than 5/10, a very small adjustment to the middle leveling screws to either lift or drop the table would be required. Only the values from front to back can be effectively changed by adjustment of the middle leveling screws. If the adjustments to make spindle sweep better are very small, you don't need to check bow and twist again. Lock the leveling screws in place. Tighten the locking nuts while holding the leveling screws so they don't rotate. The customer's machine is now at the proper height and level and is free of any twist or bow in the base casting. This provides the basis for optimal machine accuracy.